Editor-in-Chief of Dryland Research and Management, served as Arthur Lecture Chairman in the International Union of Soil Sciences, Commission Salter of Pizarro, serves as elected chairman of the Hungarian Soil Sciences Society. One more minute. So using this.
Hello, everybody. Good afternoon, and I appreciate very much this opportunity to be here with you in this conference. I learned a lot. I think it's a very good thing to have it regularly here in this place in the middle of the desert, and I was happy to be part of this session of geoecology. So and my talk is focusing on salt-affected landscapes in my native country, Hungary. And we start with this picture, which is a classic of painting over there, showing the steppe of a very famous painter over there. And on this picture, you see everything what you need for a salt-affected land over there, except we don't see funny. So we see the atmospheric elements. We see that there is a big rain approaching. We see, of course, not related to the salt-affected soils, rainbow, and we see the surface. We see water on the surface. We see the typical wells over there and the plants over there. We don't see the animals, the grazing animals, which are very important part of this ecosystem. And this is the abstract of my talk, which is there will be several parts of the talk. The first will be a rough introductory section on the issues of aridity, especially in Hungary, based on newspaper titles, basically, without going to deep explanation. Hungary is located in the Pannonian or Carpathian basin up there, and we shall see the neighboring countries. This is Ondieki, and this is Italy, and roughly this is the area that we shall be focusing, and it has several climatic zones. The lowland is the drier and warmer part of the country, as is typical. It has different soil types. This is Hungary by the Danube, sorry. Coming here you already seen Vienna, Bratislava, Budapest, and there is also to the south, fourth capital by the Danube, and this is Rhoda. You will see it later on the map, and what is more important is that we see the soil types, and we see the salt-affected soil types here, the solonets. This is the WRB, World Reference Base classification system. We see up here the solonets, and we see the solon chart, and most of the aridity problems are related to too much. So to the areas here, and also some years it's entered already to the titles, articles, in journals, British, to problems of irrigation, food, temperature, and of course on the news, there are new birds arriving anywhere, pests, different problems for farmers, and this is here. We do everything for see on the and in this section, I will talk about one particular region of the new the general introduction of the science, zonality, vegetation there, something with fauna, and then we enter to we see a particular area, and we see the relationship between hydrogen. So we have some episodes, and of course but determine what kind of salt will be there, and what will be the properties. So climate, hydrogeological situation, and land use is the order of these. We are now speaking about a definite area, and here the hydrogeology is inside this area is dominant one, and now you can see the four capitals by the Danube here. And we shall see this transect, the red line, and remember that this transect will cross the Tisza River 2 times, and it goes to the Danube River. And we shall see what is under the surface. And under the surface is the subsurface water system, which is determining the route of the groundwater, and this is very much related to the accumulation of the soil. So we see on the higher areas the recharge areas, and in the lowland we see the discharge areas at different distances. And the discharge areas typically are related to accumulation of the soil. And the driest area here is up here, which is entering the newspapers as desertification in Hungary. So don't be surprised if you read about desertified Hungary in the papers, which is of course not real, because better years comes and then the situation is better, but evidently this is a focal point of heredity in Hungary, where there is a recurrent drought from year to year. And we kept the same transect, and this is the map of the salt-affected soils. This is a kind of exaggeration of the situation, because you cannot make a map with every small little patch, but evidently in the lowland this is a very typical formation, but also there are high quality lands, and the productivity in the lowland is quite good, although salt affected soils are widespread. What is the main factor of the accumulation of the soils there? We already spoke about the water, and of course we need the salt. The salt is in the shallow water table, and this situation, quite old but still valid picture, shows us that when the zone of the wetting, because of the snow melt, will overlap with the capillary fringe of the saline water table, and comes a dry period, warmer period, immediately there will be very strong accumulation of the salts near the surface. Sometimes there will be salt crystals, seen efflorescences on the surface. These are the moments of very strong accumulation. But after that comes again green period, and that will be leached down. So this is the interplay of accumulation and leaching. In this area, it's 550 million. So our soils that I'm now speaking about are sodic soils. So it means that they are somewhat leached. The main problem is the sodicity, the high level of exchangeable sodium, and not the high salinity level. We have the saline soils, but in this talk I will focus on these ones. And they have very special properties. For example, they can be acidic in the surface. Such acidic, I will talk about later, that for their reclamation, liming material is used, just as for an acidic soil, normally, because it will improve the structure there, and also provide, of course, the calcium for the plants. And then see what is on the surface. There is a very characteristic special variability based on the surface. This is a fescue-dominated land in the Hortobágy. We shall speak about the Hortobágy in the following section. Hortobágy is a national park, actually, and it is one well-known region with legends and with many poems and talks related to that, and customs. So well rooted in the national tradition. Earlier it was, and still it is a very important region, step for raising cattle, and that cattle earlier was transported to Western Europe and was sold at good prices. Something similar happened here, like in England, that when after big campaign of wars, the population was driven away from here, then the local towns got hold of the land and didn't permit the people to come back, because having cattle was much more profitable than having their cropping land, because in small patches of the area you could crop the land. Those were fertile. But now, go away, we want to have here cattle because that can be sold in Germany, Italy, or other places. And this is the typical relief there, and you can see that from non-saline areas to, again, non-saline marshland, the marshland over here, sorry. In between, we have the salt-affected types of soils, and with related vegetation, species, and also the soil properties. These should seem very low values, and these are very low values because these were measured on the surface samples, a few centimeters of the surface samples. That was the only available data set because there were no salt-affected patches also, as the woodland steppe and also the marshland. We very rarely go into the marshland, but in one study we collected the samples. We measured these values immediately there in the field, and therefore these are very low. You will see the real values that are characteristic for the soil horizon. So just a few centimeters of the surface were at this one. And let's see the typical soil profile. As I told you, the data will be shown later, but very important to say that sodic soil has reached surface horizon under which there is an alluvial natric B horizon. This is the name for that. Natric means containing high exchangeable sodium, and in this area the sea horizon is typically derived from lush or from overworked river sediment, but very often mixed also with some loess, which was deposited there during the Pleistocene. And between the E or A horizon and the alluvial horizon, there is an abrupt increase. You can see the color, of course, but plainness, salinity, sodicity, alkalinity, and also the structure and the calcium carbonate content is increasing. So much that earlier some geologists supposed that these come from different geological origins, that it was deposited, it's a very fresh deposit of rivers, and that was an earlier deposit. But recent theories do not support it. And here we see a cross-section of the soil here. You can see that there is a very strong stratification. The first number is the pH value, and these are associated. And the second is the in 2.5 suspension, and these pH values reach up to 10, but also you can see that close to the surface we might have pH of 4.6. So of course this is not a cropland, nobody thinks of that, but some patches have better options for cropping, and this is a very particular micro morphological feature there, where there is some erosion, and we distinguish the top of this mound and the lows here, which have different vegetation and soil properties. One characteristic feature of such micro morphological arrangement is the difference in the temperature. So the red means the warm, and the blue means the not so warm, and in here you can see that in the middle, where there is the bare spot, the temperature can very much higher than in the cooler places, such as in the meadow, which is the coolest, and even on the steppe. What is the reason? The reason is the cover of the plants, of course, here. Because there is good plant growth, it's wet, it's not so dry, and also the tall grass steppe, but in the middle, where there is no protection, so the temperature is very high. It remains a cardinal question for later issues. And now coming to the animals, These are the different vegetation types here in the different columns, 3 different vegetation types. The first is a meadow, the second is different classes of short grass steppe, and the last is salt-affected sodic patch, and there are different grasshoppers living in this area. This is a table already 80 years old, and the entomologists already realized that what is the importance of the altitudinal zones. The same thing was proved for the birds. Here we see the dry and areas, and up there is not much salt here, and then we go to the most salt-affected areas, and we enter a somewhat wetter habitat here, and you can see that the lapwing, the skylark, the stone curlew, collared protincor, and short-back find its places in different elevational zones. All these birds are living here. And if we continue this in the wetter parts, again, here in the somewhat salty area, and then to the wetter, there is not so much salt longer. If we go down, we can see again the different habitats which are suitable for different birds there. And going to the the grazing animals, you can see the different hierarchy there. So the upmost zone is used for cattle grazing, and then for the same level for horses, and then there are sheep, and there are the pigs, and recently there is Przewalski horse. It's breeded there. It was collected from different zoos, as before taking back to the original places. Their number is increased there, and the water buffalo is a traditional animal there, but their number is not so high. And if you now see the hierarchy of the herders, then we see that they have different heads, and when they are meet in the pub or roadside inn, then there's also the hierarchy. I barehead very often, yeah. But of course you can see them. Most commonly we see shepherd boys, because my work focusing on this area where there are the salt accumulations, and we rarely go up to the high quality grassland or down to the marshland where the pigs are. So we see more sheep than other animals. But this is a very typical Hungarian breed. That was the one which was walking over to Germany from Hungary in the medieval times. And an interesting feature is that all over the lowland, the most widespread near nature vegetation type is the salt meadow, because in other areas the original vegetation disappeared and it's used for cropland, but in the small patches you don't have to imagine again the continuous large patches, but these are small areas where this remained. So we have good cropland, but still, since the elevation is different from point to point, except you could see that these are the biggest patches of the salt-affected land. This is mostly salt-affected land. And salt meadows are our most widespread vegetation type without trees there. And now we focus on the small scale work. That was an area of some 300 meters long, where we were working together with a geologist, hydrogeologist, and other specialists. The elevation difference was 1.5 meters here. There were many geological bore holes down to the depth of 10 meters. Altogether, something like 50 boreholes were there. And then each borehole collected also the shallow water table sample, which went to the laboratory. And we established 4 permanent water table observation wells. And we also created some 400 measurement points for surface salinity checking. And we shall see the results of these projects. There were several projects overlapping here. So this is only one geological transect there. And we could see a large variation in the different sediments. So this is the river sedimentation plain of the river Tisza. And logically, from time to time, after different inundations, different kind of sediments were put down from sand to clay. Close to the surface, there is a clay layer, and this is very much suitable for keeping the salts there when got over there. So a barrier for leaching the salts from the surface layers. And here we see the groundwater level above sea level, and it's following more or less the elevation pattern, but we see again large differences here. The next map shows the salt content of the groundwater, again quite variable inside this area, from less than 1 gram per liter to more than 10 gram per liter in the water table, and also the composition of the groundwater is very different from kind of pure chloride or sulfate or hydrocarbonate. These are the 3 main types, any kind of mixture of them, you can see. And this is very difficult to explain, of course, even for hydrogeologists. This must be related somehow to the original sedimentation pattern that soil scientists have to accept. As to what to work with. And the surface salt efflorescences reflect the composition of the groundwater. As we can see, it's small differences, less than 200 meters, were quite big differences in the composition of the efflorescences. And now we come to the explanations. So when we were analyzing the pattern of the shallow water table, 4 wells are shown here. Maybe you remember, that was the topmost, and that was the deepest well. And normally, this blue line, the deepest is quite deep, except when comes a high precipitation, when it can rise very much. And these dynamics here, from deeper to higher, means that since it is height above sea level. If it's higher than the nearby, not so deep well, there is an opportunity for the reverse flow of the water. So it creates conditions for mixing and for keeping the salts there, which are already there, not leaving the system. This diagram shows the composition of the groundwater in different times, and what we can see that some of the groundwater wells have relatively stable composition, others have changing composition, maybe which is related also to the groundwater flow between the different wells. Also, we can see that related to the cations, the sodium is the only dominant one, with a minor role of calcium and magnesium, but in terms of the anions, there's a complete mixture of them. We had a look at the ratio of bromide to chloride, which should show a relationship between the different layers. On this figure, we show 3 soil profiles and the underground water. So from each soil profile, horizon A, B, B, C, and C is shown together with the groundwater. And we were looking at the relationship between these layers. And the simplest thing was that we found was the profile HS, where we found very simple increase of the concentration from A, B, B, C, C to the groundwater. So, but it shows that there is a continuous mixture of the salts here, and both evaporation and mixing from the rainwater is going on. In the case of the other 2 profiles, we couldn't see that, but we could realize that the groundwater chloride concentration is higher than in the soil profiles. So it means concentration, it means a large role of evaporation. We use chloride and bromide because these are considered conservative ions, which will not be taken up by the plants, but still we can see the effect of the organic matter, which is related to higher bromide concentrations here. The next figure shows us the relationship between the deep discharging groundwater and the rainwater. For that we use the stable oxygen isotope 18. And we see the temporal dynamism. Basically, there's not much change in time. But what we can see is that different observation well waters had different effect of the precipitation and evaporation. Precipitation and evaporation go together, and we rise the level of the stable oxygen. And in the next figure, we see verification of this based on the oxygen and also deuterium concentration. So the highest mixing and evaporation was found in the deepest layer, and the less was found in the most strongly salty patch. And since we are running out of time, I will maybe focus on the most important key points. These were our 3 profiles that we were just having a look at, and we can see that the salinity values and the exchangeable sodium values are typically in the middle section where the salt accumulation is going on. They are showing the maximum in both characters, and they have the strongest, the highest bulk density and the lowest soil organic matter content. This expressed here. And based on that, we made a theory, basically a model of the salt accumulation, distinguishing 2 different seasons. The dry season is affected mostly by the temperature difference, and since this is bare, here the evaporation is the maximum. And in the wet season, due to the very low hydraulic conductivity of the same salty region, there is no chance of leaching the salts, but there is a chance in the deeper area and also in the high area where there is high hydraulic conductivity value. And this table will summarize this for the different zones, the different processes. As told, waterlogging is occurring in the deepest area, runoff based on the specific erosional forms in the intermediate area, infiltration on the top and not in the middle, and capillary rise in the middle section, resulting in the high salt accumulation. And these points summarize this one. It's just explained to you. There is a last section based on reclamation, where I wanted to explain you what was the history of reclaiming this area. There is liming going on present, but earlier the use of non-saline subsoil was typical. This technique is not used any longer. You can see this is a soil profile that here somebody layered this yellow subsoil, and on this place there you can see sometimes collecting water on the surface. And if you use every means that you can use for improving such soils, then you will use chemical reclamation, you will use drainage here. And in this plot, we did that, very similar original vegetation that you have just seen. And when you see the different kinds of reclamation, you can see that there is difference. It was mirroring the original difference of the soil properties. So if there was no reclamation of the deeper layers, it was not needed there. And there was drainage, or there was surface water management, and we compared the unimproved, the reclaimed, and the drained kind of treatments, and we saw already the difference in the surface, the decreasing salinity level, and the decreasing solidity level, not only for these parameters, but also in deeper layers regarding pH and increasing soil organic matter and improving hydraulic conductivity. And I come to the very last slide. How are these areas protected when they need protection? By salt-affected soils, and now we are again going to the national scale, we have to mention the salt lakes. We have many salt lakes, and most of these salt lakes already not salty because of the sinking groundwater level. In this area that I was talking about, the Hortobágy is not so characteristic. But in the sandier areas, there is a very deep groundwater table sinking already, and their future is not sure, but there are efforts to bring that the water back, because these were canalized by the people who didn't want to have the water early in the spring. They want to get rid of them for easy cultivation, and that's the case of the salt lakes. And the other areas, the sodic lands, are mostly covered by national parks, and there the management is fixed, so their future is sure. Thank you for your attention. To speech tender and ions. Yeah. Yeah. As I showed inside the area, the composition of the ions and the groundwater is different, and also the soil layers. And there is a relationship between the composition of the ions and the alkalinity. The alkalinity is created by hydrocarbonate and carbonate ions. In this area, hydrocarbonate is typical, and chloride and sulfide are not so much related to alkalinity, more neutral. Exchange of place to place, but this is a characteristic feature of soil classification. So for the sodic soil, we have three different kinds. One has the
estimate layers not deeper than 7 centimeters, the others are between 7 and 15, and then the surface under 50. And sometimes it's even deeper, and then it's covered. So you can say that the most extreme layers we have just to and which will not be touched. So, but also you can find deeper layers. Only the areas with ecological layers. And in this experimental arrangement, it was actually one factor which was considered for the productive layer increase during the experiment. Yes, this is the figure that I didn't try to explain. Because the experimentation is for 25 years. Favorable for growing their wheat. This is the typical process. Yes?
So how would you see any of the effects of the climate change elevating the temperature?
Yeah, it's a very good question. Since this area is not drier in the term of the precipitation stays the same. But since it's warmer, then it's dry. And becoming drier has two effects. First, it has an immediate effect of keeping the salt close to the surface. But the second effect is the sinking water table. And if the water table will sink, then sooner or later the immediate connection between the soil and the shallow water table will be lost. So there is expected desalination in the soil. Yes. In the very long term. But I think in the very long term there will be more precipitation because the general warming will result in more precipitation all over, but still we are not there. Still we are in the area when the local factors, meteorological factors, determine where is the surface of the water level. We don't know this is. But we don't know this is my idea. Thank you. Thank you.
Thank you, and may I take this opportunity to thank the organizers of this particular conference, and also the chair of the session, and the colleagues who are making presentations, and of course those that are attending. Making this presentation on behalf of my colleagues. Rhoda is a member of staff at Dryland Research Training and Ecotourism Center in Kenya, and Beatrice Cherek, she is a member of staff at the University of Eldoret in the Directorate of Resource Mobilization and Strategic Initiatives. Rhoda was the person that was supposed to make this presentation, but unfortunately, because of work-related engagements, she is not able to attend, and so I'm making this presentation on her behalf. So the presentation is on understanding the anthropogenic effects or pressure, of course, what it has or it does to the behavior and dispersal patterns of an animal that we call the greater kudu, and Tragelaphus strepsiceros within the Asals or the arid and semi-arid lands of Kenya. So we can move on to the next one, and or I can use it. I can use this one to move. Is it okay? All right. Let me see. Yes. That is the animal that we are talking about. How many of you have seen it? Oh my God, I can only see 3-4 persons. Now, this is the greater kudu that we are talking about. And to the left of the screen is the male. And so sometimes it's very easy to spot an animal and tell this is a male because of the horns in that case, and it's relatively bigger. And when you look at the left side or the right side, you have the female. Now these two, or these particular species of wildlife, is very endemic to a particular region in Kenya that is called Lake Bogoria National Reserve. And within Lake Bogoria National Reserve, we have a very good and very unique geologic formation that allows plants grow in that area that happen to be food for this particular species, but also important are the salt licks that are found in that area. So it's more of a geological formation that favors these particular species in this area. So plant and the salts that will, to a large extent, drive the dispersal, the distribution of this particular species in this region. And so as we move along, what you'll be seeing that is affecting this, besides the geological component or composition of the area, the plant composition of the area, there is also the anthropogenic factor that is controlling this distribution of these animals in this area. Okay. Now, these are some of the statistics or the information that we have, especially from the Worldwide Wildlife Fund 2022 and Ogutu 2026. According to them, registered declines in terms of abundance of the monitored wildlife populations could be attributed to some extent to anthropogenic pressure. And we are talking about population increase. We are talking about pressure that is coming from expansion of agriculture and all that. And within Baringo County, which is the area where this particular species is found, we have experienced up to 85% loss of wildlife in these areas, and it is a major concern for not only the country but the region in terms of tourism, in terms of livelihoods, because these are regions where predominantly the livelihoods are dependent on tourism in that area, and therefore by extension on food security and environmental sustainability in that particular region. So, and these declines have been associated with to this rapid growth in human population in that area. We are talking about change in climate and of course variability associated with it, and thus it means that any interventions that we'll be looking at will be revolving around the arresting anthropogenic pressure besides the human, besides the ecological aspects. So as I've said, in Lake Baringo, or Lake Bogoria National Reserve, basically tourism is the one that is the key livelihood in that area. And of course, as I said, you will definitely see that a combination of landforms, biodiversity, and all that provides the ideal habitat for this particular animal, the greater kudu. Anthropogenic pressure has proven to be a concern and a point of concern, and it's affecting the feeding areas, it's affecting the watering and dispersal areas, as well as the breeding grounds for these animals. Therefore, for us as ecologists, as scientists, environmentalists, we are interested in understanding what really is going to happen to the habitat of these animals and how is it going to affect livelihoods within this region. The specific objectives for this 10-year study was basically to relate the land use, land cover changes to the dispersal of this greater kudu in that area. And number two, it was to investigate the knowledge, attitude, and practice, especially among us, these community members in this area. How is it contributing to dispersal and conservation of these greater kudu in that area? And so this is work that has been done for relatively a long period of time. And our argument is based on this kind of a model. And in this model where we are seeing people, nature, and management playing a huge role in terms of wildlife conservation. And therefore, you will see that there is going to be evaluation, there is planning, and of course, human beings are there leading that change and implementation, including the interventions or policies that have been agreed upon. They are going to play a role in wildlife conservation. And therefore, the model that works for us, especially theoretically, is the driver pressure state impact response model, whereby we will be looking, or we looked at the driving forces behind the greater kudu distribution in that area. We are looking at the pressures, especially associated with food production within that area, and what really happens as a result of the pressure that is coming from human activities. And then there are impacts. Of course, the impacts will be either you are driving these animals out of their conservation area, or there is going to be wildlife or human-wildlife conflict as a result of lack of food or habitat resources that are important for the survival of these species. And of course, the response has been, and to a large extent, policy interventions or legal frameworks are being put in place to arrest the undesired impacts in terms of wildlife conservation in that region. This is in ideal what we looked at. If you're up there driving forces, will be agriculture, the transport industry and all that. You are looking at pressure. It's going to be resource use. This is an area where people are competing for the various resources, including pastures within that area between the pastoralists, and there is agriculture. There is which means they also need water, they need land. There are changes which are going to be happening within various compartments of the environment, whether physical, chemical, or biological. And then the impacts are going to be either socioeconomic or it's going to be environmental, and the response will be taking several forms, including the policy interventions that I talked about. The study area, as I mentioned, is within Baringo, which is in the Greater Rift Valley and to the north of the Rift Valley. And for those of you who have been to Kenya, I don't know how many of you have been to Kenya. This guy is here. Good, thank you. I can see a few. This is one of the lakes, or the study area is around one of the lakes that is within the Rift Valley system, which is famous for flamingos. And for a long time, we have been keen talking about flamingos. And so flamingos will be in this lake Bogoria, Lake Baringo, Lake Nakuru. And that is the area where we also have the Lake Bogoria National Reserve, where you have the Greater Kudu. That is the only region where it is. And as I said, it's an area which is very unique to these animals. Of course, with the alkaline hotspots and, of course, the vegetation that is unique to this area. So, acacia woodlands, and of course, being an area that is dry, we expect not much of rainfall beyond 900, or not 900, 600, but occasionally of late we have had figures which are relatively bigger than that. It's in the North Rift, as I indicated. This is the area where we did the mapping, and of course looking for these dispersal areas for the kudu, relating it to anthropogenic pressures as a function of what I've just mentioned as land use, land cover changes in that region. So the population, as you can see, has been on the increase, and of course from 2009 still, you are seeing ourselves in 2019. Today, if you go there, it has increased further. The study methods in terms of the research design, we not only counted, but we also did the land use, land cover using the GIS methods. Of course, we did the household surveys and of course observational studies, which were done over a period of time. And these two objectives, one is the use of satellite images from Landsat, and the other was, of course, the household and cross-sectional survey for the other objectives. What is it that we found? Of course, over the years, what we have, especially in the last 6 years, is an increase. If I had a pointer, I could show you, but let me see if I can point. An area like this one, I don't know whether this one is being seen. No, it's not being seen. But where? Yeah, sorry, there is a stick somewhere. Oh, good, thanks. See now, this is good. This is more like what we know, not the pointers. So this is one here. The density here, it indicates to you or to us that this is where it's more dense, actually numbers that are above or 20. And around it, the numbers are relatively like 5 to 10, and then below 5 is a bluish one that is out there. And it's the same that you are going to be seeing in all those areas. Now, around those points where the kudu population is being found, if you look at them, There are areas, number one, that are characterized by vegetation that is around them that is ideal for these animals. So either they are providing, number one, feed resources, so the vegetation is good in terms of as being food resources, so the forage is good, or there were also areas which are providing cover for these species in terms of away from predation or from people who are hunting those animals. The other one is that there could be areas where you have fresh water sources around them, like water ponds, some of them that are around those areas where you are seeing a high concentration of those animals. So the ecological needs were driving the dispersal, water requirements, and also food, that as I've said, breeding behavior. And of course, as I have said, it's going to be mostly in those areas where you will find these animals present. Okay, and therefore, those areas where we also find that human population is relatively high, it's also where the animals are running away from, except those areas where you have crops. You could easily find those animals invading people's crops and therefore resulting in human-wildlife conflicts in those areas. Previous studies, especially by Kitina and Odiara, they have also indicated that populations of wildlife could be affected by land use, land cover changes. And what we saw is that as time went by and the areas were being affected in terms of their the land use, the land cover, you could easily see a slight shift from the traditional grazing areas to other areas where there is water and, of course, vegetation cover that could be used by these animals. If you look at the different land use cover classes that we have, the one that experienced the highest is build-up, which is this one here, percent change of 300 plus 350%. Also followed by agriculture and the water here. Now, these two relate very well with what we know. As we saw, the population was increasing. What you also expect with it is an increase in the built-up areas. With it, of course, comes in food requirements and therefore a demand for food. And then, of course, the increase in water was a result of unexplained flooding. We cannot tell up to now exactly whether it's coming from underground or from above ground. So, where the waters were coming from that were causing flooding in those areas. From the responses, that is the household surveys, what is it that we found out is that men, so males, this is what I'm talking about, they had a better knowledge about the wildlife conservation, especially the greater kudu. And of course, this has also been found out that because partly the men have been keen on land reforms within their area, or they are keen on land tenure systems, they could be the ones because they understanding more about what changes are happening on land and how they are affecting their lands. And therefore, it's important to consider gender mainstreaming if we are to get somewhere in terms of land or animal conservation to be better. The other thing that we also realize is that those that own land, they were also more knowledgeable than those ones that are renting land in those areas, and therefore they will play a huge role in the greater kudu conservation. There is also, when you're looking at land tenure systems and poor land use policies, they could also be part of what explains why we have low numbers of kudu in some areas, and this has been supported by some of these studies that we have seen, and is the reason why we have moved in the direction of establishing sanctuaries and conservancies to help increase the numbers of these animals in these areas. So land ownership is key. Then from our focus group discussions, we also found out that the greater kudu population has been increasing in some of those areas, partly because of the support from the local communities and also activities which are supportive of wildlife conservation in this area. Could be like apiculture, which is basically beekeeping, which is very supportive and very consistent with sustainable wildlife conservation or conservation of wildlife on a sustainable basis. This is beekeeping. Taboos and culture could also be playing a huge role, especially in decreasing the population, and also there is need for continuous monitoring of this wildlife within these areas. The strategies, this is towards supporting wildlife conservation and especially the greater kudu population. One could be increasing their watering points within that area. Number two is to monitor or to ensure the corridors are identified and preserved, meaning if the animals are moving this area to their feeding area, they are moving to watering areas, we must conserve and of course preserve those corridors. Number three is pasture production as a substitute. We found out that there is a lot of human-wildlife conflicts in these areas, and therefore it's necessary that we have pasture production for the pastoralists or the agro-pastoralists to prevent these kind of human-wildlife conflicts in this area. Then revenue sharing, especially from the proceeds of tourism with the local community, they must be brought on board. Continuous monitoring of this kudu population, annual population census, or the sampling from time to time to map out where they are really dispersed and what is really moving them around those areas is key. And finally, we need capacity building, especially for those involved in wildlife conservation of the kudu. Monitoring, you are trying to understand their dispersal areas, and of course, education for sustainable development for the young children who are in schools and in high schools and even in primary schools. They need to be involved in the conservation activities. From where I sit, it's only not moving, but let me see. It's hanging at the last tail end. Technical person. Technical person, there is something that I just wanted to say one more, but it's hanging. Maybe, but as I finish, oh, there you are. Thank you. What I wanted to say is that it's recommended that we have an all-inclusive adaptive management and conservation strategy that embraces those aspects of continuous monitoring and understanding the dispersal areas, and that will basically enhance livelihoods and of course the conservation of the kudu in this area. This work was supported for a long time by IGAD, that is Intergovernmental Agency on Development, UNDP, Global Environment Facility, the University, Egerton University, the Center for Sustainable Agriculture and Management, and the County of Baringo, as well as the Kenya Organic Agriculture Network and the government of Kenya. Thank you, ladies and gentlemen. Thank you for that question. The number one thing that you said is that acacia, there is a lot of, it's acacia woodlands in that area. Now, the acacia species, in most cases that they are feeding on, there are three kinds. One is Acacia mellifera, there is Acacia totilis, there is Acacia brevispica. Some of them are browse in nature. They are shorter, they don't grow tall. Therefore, they are within reach where the kudu is going to be grazing. And of course, there is another species that we call Balanitis aegyptica, very common one, also that is being fed by this particular species. One of the things that you will find is that as they browse, they are also basically helping in dispersal of the seeds within that area, which is, of course, as they feed the seeds, they are being dispersed, especially for the Balanitis aegyptica. They eat a lot of those seeds, and therefore, ecologically, they are playing a huge role in transforming that particular ecosystem. Now, the other component where you are going to be seeing them, the livestock in the area, especially the sheep, not the sheep, the goats and cows, but mostly the goats, you are going to see them also keen and interested in the Balanitis, but mostly they live the herbage. And therefore, there is going to be some kind of a conflict there. But as they eat, they are also able to maintain the height of some of these plants, such that they don't grow too tall for some of these livestock that are they domesticated within that region. But in essence, they play a role in maintaining that particular ecosystem, but they also play a role in making sure that the area has the kind of vegetation that is used by the wildlife and also the livestock within that area. Yes, thank you. Yes. Yes, very good question from my friend here. Now there is let me see if I can go back here quickly. There I am. The horn. This horn, for the local community, some of them, they use it during the rituals. They can blow the horn, and they are calling people to the area for some functions. They could be passage of rites. So some people previously, not so much now, they have been keen. They can kill this animal only interested in the horn. But because of sensitization, because now they are able to understand that this animal is located within that area only, they have started embracing the support initiatives towards their conservation to make sure that the animal is actually protected. Now, and that is where you realize that community policing, especially for wildlife conservation, is key. People understand and they value the animal and they want to make sure it's protected. Nobody is going to kill it. So they are now reporting to others, I saw him, he killed this animal. And so it's now better than just having government agencies with wardens and all these people are taking care of the protection of these animals. Now, the hunting indeed was affecting the population before, but today it's now a collective effort from the community and the government agencies. Less hunting, yes. Predation, there is not much because of the size and the kinds of predators that are here. They are not large predators like lions. They are not there. So what we have are smaller ones, a few leopards, but not many. And of course, not many hyenas. You have serval cats and all that, but they are not those. If lions were here, they could be the target now. Yeah, in this case. Yes. They are. Actually, they are. Yes. Yes. Oh, yes. That's a very good question. Now, the interaction is, of course, going to be when it's very dry. You will see them moving to people's homesteads. They are looking for crops. And in some areas, we have had wildlife or human-wildlife conflicts. It's because they have moved or strayed into people's croplands. And previously, actually, people used to kill them. But today, because of the policy that is in place, you will be compensated, actually. The compensation happens nearly within a month. You will be paid for what was lost. And this is through the county government interventions. There are county wildlife compensation steering committees, like now for Baringo, and also the government through the Kenya Wildlife Service. Now, they don't see it as something that they want to kill, but rather we report the loss of those or the damage to their crops, and they are going to be facilitated in terms of being compensated for that. But also most important is that we have, through this research that has been done for some time, we proposed that we have watering points within this conservation area. So you expand, you increase the watering points and make sure that they are able to get to where water is, and you reduce that interaction with the local livestock populations. That's okay. Okay. Now, if you have an area that used to be, for example, a migratory corridor, animals are moving from point A to point B, but along the way, because of increase in population, the corridor, you are building a house or you are going to convert it into a farmland. What is going to happen is that these animals are now no longer able to move along that corridor. Instead, they will be either going through that area, they destroy your crops, or they are confined to that area. A population is confined to an area up there, another one down this side. Now, that increase in agricultural land denies them habitat. Habitat with it has water, has food, has cover, which could be also breeding areas. Actually, some of the breeding areas, we found out that the community had moved closer to the conservation area and turned those areas because they were prime areas where for them they could grow crops. But for the kudu, it was breeding areas or breeding sites for them. And they choose certain areas for breeding, for example, and they are not going to do it elsewhere. And why? Because they could be protected areas or areas which also have the kind of food that they are looking for, or the kinds of minerals that they are looking for, especially for the young ones when they are growing those areas. So increase in built-up areas, increase in agricultural farmlands contributes to their decline in numbers, or they could affect their dispersal within that conservation area. Thank you.
So how could it sound like if we wouldn't actually work together? We're working on the same project. This is one of my supervisors. I'm very happy to be here. I did a master in this institute here. So today we are going to talk about the part of my PhD work. The thing I like the most about my PhD is that it is interdisciplinary. But this interdisciplinarity is kind of making the story very complicated, and I'm going to try to say a complicated story in non-complicated ways so that we understand everything. But it's probably going to take some information out, and I hope that I'm going to be able to fill the gaps at the end if we will have it. So we're going to talk about the animals-induced geodiversity and how the animals are actually influencing the geo-ecosystem functioning along the different aridity levels in the Negev Desert. I wouldn't like to take the microphone because I'm a very loud person. So thank you very much. We have in general in Drylands, we have a lot of features like shrubs, rocks, interspaces, known features of biodiversity that we claim to know very well, and we have generally studied them a lot throughout the academic world. But animals trampling appears still as a novel element that is kind of changing the information that we know about the geo-ecosystem functioning. They're almost like a hidden gem of this desert that are changing the functioning and ecology and the geomorphology of these deserts, and we know very little about them. So I hope that I'm going to manage to convince you today that they are one of the strongest hidden modifiers, but if not the strongest, definitely the least studied modifiers of the geo-ecosystem functioning in the Drylands. So how we know about these systems so far in this Negev desert? We have widely studied them as the two-phase mosaics that are composed of the shrubs and interspaces. So shrubs are considered to be the sink areas, and interspaces are considered to be the source areas from where we are getting the run of water that is being accumulated in the shrub areas. So animal trampling routes technically add to this third phase. They are compacted microtopographic elements that are absolutely changing the water redistribution over the hill slope, which consequently changes the distribution of the resources, be it water resources or the soil resources that are coming from the material that is being transported. And all of this is consequently causing the biodiversity or vegetation to respond in a unique way. There was some study in one of the study sites in the Negev, in Lechavim, that called this system as a three-phase mosaic, but the third phase that was considered there was actually rocks, because the rocks are the main source of the water runoff, and this is a very unique setup in the Lake Avim area, as in the rest of it, as we are going the southern and we are increasing the aridity, we do not have such a high rockiness. And anyways, we are not excluding rock as a phase, we are just considering the rocks as a part of the surface roughness that is anyways influencing this complete system is located in the interspaces areas. So if you take a closer look at them, this is the pictures taken with drones in there is a very high resolution orthomosaic. We see that they are not really random, they are really engineered by the animal trampling. I'm not going to talk about the mechanisms that animals are using to graze, because this is not my main aspect of the story, but doing that unintentionally, they are creating these terraces like a micro beams that are acting as a water harvesting systems in the desert. This is an example of a transect where we see that the average hill slope has an inclination of 12.8 degrees. But these routes, I don't know if you see them, but there are these little sections here, are actually having the complete change of the slope of the terrain, where we have the inclination of only 3.3%. So only this flattering of the surface alone is changing completely the hydrological connectivity of every hill slope where they actually exist. The slower the flow, they create more of a concentration and definitely the different distribution of the resources, as you mentioned earlier. So, geoecosystem functioning, as we are seeing it now and as we are studying it now, is composed of these animal trampling routes that are consequently modifying the hydrological processes as seen to hydrological connectivity, which modifies the geodiversity, and as I said, as a consequence, this modifies the biodiversity or vegetation response. We understand these elements as separate features, but what we do not really know about them is what is their feedback of networks and how they are now all together creating this geoecosystem functioning. Technically, what is their influence on this geoecosystem functioning all together and on each other. And this is what we are going to try to answer today or touch on it today. The main research question that we are asking is how do these trampling routes then reshape the Dryland slope, hydrology, geodiversity, and biodiversity, and how is this going to different along the different aridity gradients. In Israel, and one of the very nice things that I love about Israel is that we have this beautiful meridional stretching of the country that allows us to observe and study multiple different climates or different aridities. I'm going to refer to it as different aridity levels. So we have 3 study sites that are constructed to meet these 3 aridity levels that we have in the Negev desert. We have Lake Avim as a semi-arid study site. We have Avdat as an arid study site. And for those that aren't from here, we are actually very close to the Avdat study site. It is just a bit southern than where we are sitting now. And Katif as a hyper-arid study site. Our study is being, okay, so yeah, it did overlap, but I thought to go to scenario. Sorry for this. It's probably some modification as the conversion of the years of the present PowerPoint file. So, in these 3 study sites, our observational setup is technically conducted on 2 hill slopes, those north-facing hill slopes and those south-facing hill slopes, and we are doing our study on 3 microhabitats, on the routes, shrubs, and interspaces. So this study is touching on a small scale geodiversity and biodiversity. We are not observing everything locally on the level of the ecosystem. We are talking about small-scale biodiversity and geodiversity and how this is actually driving the geoecosystem functioning along the Negev desert. We are sampling the vegetation and the soil, and we have the GIS and remote sensing sampling of the data. Our research was conducted over the 3 years. Vegetation was sampled over 2 years. We have 480 samples of vegetation. the exclusion of the graphite study sites because we were not lucky enough to have a single rain event that is going to technically cause the booming of the herbaceous vegetation in this hyper-arid site. Then we have the soil samples that were collected over the 3 study years, and we had 432 samples that we are studying. I wanted to not go into the details, but we are definitely going to come to some of the elements that we are sampling here, right? Like, not all of this that is mentioned is going to be spoken about like in this specific talk, but we are collecting the for this specific talk, we are going to talk about the hygroscopic soil moisture, calcium carbonate, pH values, electrical conductivity, label organic carbon, total organic carbon, variability indexes ratio between the two, and the soil quality index. And with the vegetation sample, we are calculating per every square that we are sampling in the desert, species diversity, composition, and biomass. So I hope it's going to help a bit when we are going to come to the results, although it is maybe going to also be messy because it's a lot of different elements. And when it comes to the GIS and the remote sensing, we were doing one flying of the drones per season, which allowed us to produce very good resolution digital elevation models and mosaics per year. We were sampling and mapping every point that we sampled with RTK GPS, which is a very precise location, which allows us to get a very precise location of every sample that we took. And there is some more sampling of the soil using the hyperspectrum analytical device in the lab. So all of this was analyzed using the, again, like a multi ways of analyzing, like a comprehensive way of analyzing everything. There is a regular multivariate statistical analysis using the JUMP software, then ordination analysis, both constrained and unconstrained analysis to see how this data naturally distributes in the 3D space, and a series of geospatial data analysis. We are going to touch on some of them today, again, not all. This is going to be a bit complicated, and it's again being overlapped by my typing. Sorry about that, but I'm going to try to explain what we are seeing. Maybe I will even be able to zoom eventually. Let's start and see where it takes us. So this is the GIS model of topographic wetness index. Topographic wetness index is used like a proxy to show us the capacity of a terrain to capture water or distribute water once the water runoff is in the system. If we look at the Lake Avim study site, that is the one on your left, you technically do not see any linear formations because this study site has more of a precipitation and there is more of a vegetation, more of a herbaceous and woody vegetation, and there, like, we have technically the water flow between these patches of rocks and shrubs and this complex element. When we look in the middle section of that and graphite, we do start to see the linear formation. Do you see this linear formation? So these linear formations are actually routes. You got a chance to see them at the beginning, right? In that two-phase mosaic as a disturbance. So once this route don't exist in the system, this modeling, geospatial modeling, wouldn't capture them as such linear formations. So we're going to zoom just in one study site. This is of that where we are sitting today. And this part is actually the top of the hill. The entire graph is facing north. So this is a good example where we clearly see how the model is capturing, and not only capturing, rather capturing the routes as the areas in this system that are having the highest capacity to actually capture water and redistribute water. So when we look at the soil response to all of this, this is now constrained ordination analysis. We see that the constrained ordination analysis, or technically, RDA model, managed to explain 62% of the soil variation. So we have 3 categorical categories in this case, which are just site, aspect, and microhabitat, and looking at entire data set together. We see a very high clustering of each and every study site, and that each and every study site corresponds different with different soil measured parameters. We see that graphite is a high priority study site is more concentrated around pH values and electrical conductivity, but the Avdat and especially Lechavim are concentrated around the carbon content. So we see that the northern terracing slope that we expect to have technically a better soil quality are also positively related with total organic carbon and labor organic carbon. I don't know if we are all familiar with the ordination analysis, but technically we see that there is an increase in the values of labor organic carbon and total organic carbon as we move from the south to the north-facing slope. And there is also a particular gradient, for example, in the soil soil moisture and liability as we are moving from the route towards the inter and towards the shrub area, meaning that the shrub would have the best soil, the optimum soil parameters. When we look at the regular statistical modeling, we have to apply here the linear mixed. This is the linear mixed effect model because we are having unbalanced data set. The graphite is a high priority site, as I mentioned, so we always have the absence of shrubs. There are no shrubs there. We could have the vegetation, but we didn't have them. So we are having the imbalanced number of samples and study sites. So here you're going to see the model that is observing how these soil parameters, the measured soil parameters that I told you about, how they respond to the aspect that is north-facing aspect and the south-facing aspect, and the combination of location and the microhabitat, so that the model could actually be observed together. This might sound a bit more complicated, but if you have a question about it later, I can answer. We see that most of the variables show a strong effect of both. They are marked here in red. There is a way to further analyze this using the slicing. The slicing is done on each and every soil parameter, but as we are using the soil quality index that is calculated as total sum of the normalized values of all these parameters, I thought it might be the most clear if we look at only the slicing of the soil quality index. We kind of see the clear pattern if it wasn't clear from the analysis before, and this is that Lechavim has a higher soil quality over Avdat and over graphite, and that the north has better soil quality over south slope or south-facing aspect, and what we expected, that the shrubs have better soil quality than the inters and especially than the routes. But this microhabitat effect is much more in place when it comes to Avdat and Lechavim and less in graphite, because we are technically missing one microhabitat. This story is kind of logical and intuitive until we look at the vegetation, what is actually happening. This is something that we also knew till this moment, and this is not the novel aspect of the story. But we sampled the soil 1 year earlier than we actually started sampling the vegetation, and only later we started to figure out that there is something very interesting happening at the route margins, so that the routes cannot be observed only as the routes, as they are creating a completely new niche for at their margins that just sit a couple of centimeters on the side. So again, this is also not acting in the same exact way in these different levels of authorities. I'm going to show you here the example of the vegetation analysis that is done only on the data set collected in the 2023. As a reminder, we have sampled 2 years of vegetation, and we see different behavior in the Avdat and in the Lechavim study site. So Avdat in this case stood out completely. Route margins had a high species richness, and not only the species richness, they had the highest biomass across both slopes. And as I said earlier, unfortunately, we don't have the exact information about what is going on in the Lechavim in the graphite study site, but we definitely see that in Lechavim shrubs still dominate, right? In Lechavim there is not water scarcity like it is in this area here, and there is no this spatial organization of the resources like it happened in that study site. So let's try to make some conclusions and see how it goes from all this story. As I mentioned earlier, we have the known source-sink relationship and source-sink model that is technically talking about the two-phase mosaic, where we have shrubs defined as the sink zones and inter-shrub or inter-zone, everything between the shrubs defined as a source area. Just as a note, there is a water flow, in this case going right down the slope, and this is how the routes are going to alter the pedological connectivity. So once we do have the routes in the system, I think that by this experiment, and especially from the example of that, we can say that there is definitely some alteration, and there is definitely the alteration of the sourcing relationships that are taking place in this study site. We see that the shrubs are for sure going to still stay a long-term sink, because shrubs do have a very optimal conditions and very good quality of the soil. But we are having a new sink zones that are actually route margin. Routes are becoming a new source zone. It doesn't matter whether they are broken and the water flows over them and breaks the distributions, or it moves the water laterally down the routes. There is a definite intrusion of the pedological connectivity, and they become a new source. And the intermediate zone in between all of these that was before a source zone is now becoming an intermediate or transitional buffer zone. So what this all means for three of our study sites and for the operational mechanisms. Semi-arid study sites, Lechavim that we mentioned earlier, we still have the dense shrub covers and the rocks which are still dominant. The shrubs stay the strongest sinks in the system. We are moving down the gradient of the aridity to the Avdal study site, and we see that we have fewer shrubs, we have more open spaces, we have higher effect of the routes, and the routes are becoming the primary geomorphic driver of this hydrological connectivity and biodiversity and species richness in these deserts. And then we have the graphite study site that I ask you to try to capture that we do have the linear formations in this geospatial modeling. You still show that there is a geospatial potential, right? That the routes show that they can capture the water the way they're capturing water here in Avdal. But they are dependent on the water event, right? The rainfall event. So without the water or the rain event, this system technically cannot provide what it is capable of providing, but the routes are definitely contributing the system. So to completely now wrap it up, we do not still understand fully what are the operational mechanisms of all three of these environments, but we do understand that routes cannot anymore be completely ignored when studying the desert ecosystem, and that they definitely matter. They are not damaged except when we are talking about the overgrazing. When we are having the controlled grazing or even routes that are abandoned, they can persist for decades, and they're actually the micro-engineering elements and drivers of the geoecosystem functioning. They are converting the classical two-phase mosaic that was shrubs and inter-shrub areas into the three-phase system that is composed of the routes and their route margins. Inter-shrub areas or inter-route areas and shrubs, and this reshaping, of course, alters the soil moisture, the water flow, consequently the soil quality, the vegetation response, and thus the entire geoecosystem functioning and resilience under the drought. So we have the elements like this animals trampling that are unintentionally engineering these deserts, and to completely understand these deserts and resilience and respond to the climate change, we cannot ignore them anymore, as we have to start treating them as geomorphic infrastructure. I hope that I managed to explain things and that it's at least a bit clear, and I am open to any questions that you might have.
Thank you very much, Diana. Kristen? Please.
It is both wild and domestic animals. Most of them are like some form of ibex, right? They're wild growth, but we also have the sheep that are mostly coming from the Bedouins that are having them as a domestic animal. It's a network, yeah. Yeah, absolutely. So this is like a dual response of the routes. When they're existing as a fully linear formation, once the water flows down the slope, not area is completely the same, right? There are areas that have them very sparse, and there is areas that have them exactly how you described, like a completely like a network, main routes intersected with many little ones. Once they are rare, they are mostly distributing the water laterally, right? Like the water, once it reaches the route, is going to slide down that compressed area that is route. And once we have more of the routes that are intersecting them or they are broken because of a more activity, they also start to flow downward, but they are slowing down the entire flow that is being infiltrated. So they're in either case doing the modification and they're breaking this hydrological conductivity, giving more time and different directions to all the water that gets into the system. Does it answer the question? Great. Exactly. Exactly.
Now, I think that case, when you're looking at what of the conservation is based on they should be having these small habitats, not to be large ones, but there are quite a number of them have now, what kinds of how are these different ones benefit from these kinds of studies? What lessons are you telling the management of wildlife? Looking at wildlife management as a function of a number of aspects we are looking at, that habitat, the water, all that, and do that
multiple aspects.
Yes.
First of all, overgrazing is never good, right? We understand that we cannot allow animals to eat everything that exists there and destroy our biodiversity. Second thing, we are not talking about every space. In Kenya, you are not in the water limited system, first of all. Okay. So, it is? So, then the story becomes very interesting. So once we imagine the area that doesn't have these animals that are trampling, we didn't allow them to eat anything. We have a bunch of grasses, they are growing, they are very happy, and we preserve that biodiversity, okay? But this is almost like a uni-habitat, uni-niche. Then they're going to start to operate under the mechanisms of competitions, things like that. They maybe don't have the rocks and things like that. But once we have trampling routes, we are actually introducing a new niche. So yes, on the level of the entire area, maybe we are reducing the biodiversity, but these routes are becoming a new areas where something new can grow. It's a new soil type. It's a new environment, new microbial community. Everything is new there. So different plants are going to start to thrive in these areas that are completely not going to even exist, maybe in the areas that are not impacted by this trampling. So this is the most interesting part, actually. So even though we are breaking and maybe reducing the biodiversity, we are actually increasing the species richness because we are introducing one complete new niche. And then it's not only the route. There is a second sub-niche that is niche, I don't know if I'm pronouncing well, that is the route margin, right? So it's more like the spatial soil heterogeneity that is now providing completely new place for something new to grow. And again, all of this have to be managed, right? Animals are not grazing everywhere in the same way. All of this is also dependent on the hill slope, right? Like on the how these areas are laying and all of this. And there is no universal response, right? I wish that we could geoengineer all of this. Maybe we will eventually. Does it answer?
Yeah, it does. Something that you really want to see that also the study of very clear is intermediate
yeah.
introduce the new environment
we are kind of spinning around that. Intermediate is okay, even when the grazing stops, but we cannot also let it completely to stop because then there is like a weathering, right, that is destroying this route completely, even though they can still stay present for decades. Thank you for the question. So the weather conditions that we're having here in these type of areas are not like a strong rainfall events that are completely going to wipe them out. So these animals, once these routes are created in space and time, that means that animals have been grazing in these areas. So they're not going to easily be destroyed. They can exist for decades. But yes, animals do have a memory, and it's not even memory, they're just trying to use less possible energy that they can use. Which means it goes where it already made its contact. And this is how they become more and more compacted in space and time, and it's going to be like that until and they're going to almost use exactly this stuff because they already, I don't know how, but estimated what is the least consumption of the energy that they need, and this is how they operate. This is how they graze it. Thank you.
Thank you very much, Mariana. Unfortunately, we run out of time. So, as a positive Mariana, I'm very proud. It's an excellent, very interesting, fascinating presentation. And hopefully, very soon, Dr. Petrovic. Tóth.
Thank you. I didn't know that he was saying this.
Also, thanks a lot for our presenters, esteemed presenters.